In this mini clip, we'll be solving inequalities involving absolute values. While we answer this question together, you'll be solving the similar problem on your own using the same technique. We are asked to solve for the absolute value of 3x minus 2 greater than 7. These absolute value bars mean that regardless if the answer inside of the bars is positive or negative, the overall answer will be positive once we take the absolute value. So we need to find all the values of x where once we take the overall positive answer of 3x minus 2, it will be greater than 7. Now this means that our answer inside of the absolute value bars, or the answer of 3x minus 2, can either be greater than 7, or it can also be less than negative 7. Because if we were to take the positive case of anything that is less than negative 7, it will in fact still be greater than 7. Now this is a little bit confusing, but hopefully once we look at each of the cases, it will become more clear why this is so. Let's take a closer look at the first case. This is when 3x minus 2 is greater than 7. So in this case, we're only considering x values where 3x minus 2 will be greater than 7. So we just dropped these absolute value bars. In the second case, things get a little bit confusing. This is where we need to find all the values of x where 3x minus 2 is less than negative 7. So finding these values of x, we can have that 3x minus 2 is, for example, negative 8, negative 9, or negative 10, because these are all values that are less than negative 7. You'll notice, however, that we don't have absolute value bars here. So once we find all these values for x, and we find the absolute of 3x minus 2, this will change all of our answers, so the negative 8, negative 9, negative 10, to positive numbers, such as positive 8, positive 9, positive 10. And you'll notice that all of these numbers are in fact greater than positive 7. So this is why we need to consider these two cases in solving our question. I would now like you to set up these two cases with the question you are given. Here's the answer you should have got. Let's look at our first case. We now want to isolate for our x variable. To do this, we're just going to treat our inequality as if it were an equal sign, since we're very familiar with solving for unknown variables with equations. The only difference is if we were to multiply or divide by a negative number, we need to change this inequality sign from greater than to less than. We won't have to worry about this in our question though, because we won't be multiplying or dividing by negative numbers. I just wanted to remind you of this. So to isolate for x, we're going to bring this minus 2 to the other side of the inequality, which will make it positive. So we will have 3x greater than 7 plus 2. In our next line, we will have 3x greater than 7 plus 2 gives us 9. Lastly, to isolate for x, we need to get rid of this 3. The operation between 3 and x is multiplication, so to get rid of this 3, we need to divide by 3, since division is the opposite operation of multiplication. If we divide this side by 3, we also need to divide the right-hand side by 3 to ensure that we don't change our original inequality. These 3's divide out to 1, so we're left with x is greater than, and 9 divided by 3 is 3. I would now like you to solve for the x in the first case of your question. Here's the answer you should have got. So now we're going to look at our second case. we're going to do the exact same thing as we did in our first case. We're going to isolate for x. So we're going to bring this minus 2 to the other side of the inequality, which will make it positive. 3x less than negative 7 plus 2. Simplifying this, we will have 3x is less than negative 7 plus 2 is negative 5. Now we need to get rid of this 3, so we're going to divide both sides by 3 to be left with x less than negative 5 over 3. I'm going to leave this in fraction form because I don't want to deal with decimals. I would now like you to solve for x in your second case. Here's the answer you should have got. So we found that when x is greater than 3, or when x is less than minus 5 over 3, we have that the absolute of 3x minus 2 is greater than 7. So we just need to write our therefore statement. Therefore, we have when x is less than minus 5 over 3, comma, or when x is greater than 3. This is our solution. But we can also write this in interval form. So I'll write or. Now x can be anything less than minus 5 over 3. So it can go all the way as low as negative infinity. But it doesn't equal negative infinity, so I need round brackets to indicate this. And the first interval will go up to, but not including, negative 5 over 3. We'll have round brackets to indicate this. Comma. Our second interval starts at 3, but doesn't equal 3, so again, I need round brackets. And it could be anything greater than 3, so it will go all the way up until positive infinity. And again, it doesn't equal infinity, so I need round brackets. And this here is our final answer. I would now like you to write your concluding statement. And here is your final answer.